All right, you guys, here we go with 1.2, which is our continuation on probability. But today we're going to focus more on multiplication rules. So the first thing we need to talk about is what is probability. And technically, or the official definition of probability is the study of randomness. But more likely, you'll hear words like likelihood or the chance of something happening, of an event happening. Okay. And just like we did before in 1.1, probability has some notation that we need to get used to. So whenever you're going to be asked to find the probability, it's going to look like this, where it's a capital P, and it says that the way you would read this is the probability of A, whatever that event is, and A will stand for event. So whether that's the probability of rolling a dice or flipping a coin and getting heads, that's what they would ask you for, but that's how you would read that. And so the way that we find probability, it says, is the total number of favorable outcomes or outcomes in the category of interest. I like to think of that as what you want, okay? The things that you want out of or over the total possible outcomes. So over everything. Okay, and it'll make more sense once we get to the examples here. But this is probability that you've done before. So even though it is a fraction, okay, it's not scary. It's something that we've done before. So this first example says, give your answers as fractions, decimals, and percentages. So that we've got three ways that our answer is going to look. So the first thing says, what is the probability of rolling a dice? That's our event, and getting a 3. So rolling a dice, we've got to think of this. What does a dice look like? Well, a dice has 6 sides with numbers 1, 2, 3, 4, 5, and 6 on them. So my top number, or my numerator, is what I want. Out of those 6 sides, there's only one of them that I'm wanting. So it's going to be one favorable outcome over the total possible outcomes, which is a total of 6 sides. Okay, that's my fraction. Okay, and then, but it also says decimal and percent. So this is where you're going to need a calculator, and I would really suggest using an actual calculator and not your phone, because your phone doesn't do a very good job. So we get a calculator. Here's mine. If I can move it. Okay, and we're going to find what 1/6 is, but we're going to type in 1 divided by 6 because that's the same thing. And when I look at that decimal, if you look, it's 0.16666 repeating. But I'm going to pay attention on the homework and see what it wants me to round to. But for this example, I'm going to round to the thousandths place. So this is going to tell me that thousandths place would be 3 decimals. So this is the same thing as 0.16. And if we look, we've got 6. So that's going to make my third decimal place a 7. Okay, so there's the decimal. And then the way we find percents is we're going to take that decimal. We're not going to clear it. We're not going to round it. But we're going to multiply that answer, what we got, by 100. And that gives us 16.66666%. And I believe on your homework it asked you to go to the hundredths place for the percent. And so that would be 2 decimal places. So we're going to say that this equals 16.67%, because if we go the hundredths place, we get 6.66, and then that second 6 makes us round up. Okay, so feel free to pause the video for a second and try to see if you can figure out what B is. Sometimes the hardest part about probability is reading the question. So take your time, really dissect the question, see if you can figure out what's going on. So pause the video and then unpause it, and I'm going to go through it. Okay, hopefully you got somewhat far, but the biggest thing here you have to do is you have to read and understand what's going on. So it says you have a bag of 20 marbles. I've got 20 marbles. 7 are yellow, 5 are blue, and the rest are red. What is the probability of drawing a red marble? We want to find red. So we need to figure out how many red there are. So when it says we have 20 and 7 and 5 are 7 are yellow and 5 are blue, we add those together and we get 12. Okay, so we need to find what the rest are. So I go minus 12 and you get 8. So there are 8 that are red. So if I want to find the probability of drawing a red, I have 8 possible ones that I would like out of 20 total. And I don't particularly care if you reduce that fraction. I'm okay if you leave it like that. And then we grab our calculator and we go 8 divided by 20, and it gives us a decimal of 0.4. So I've got equals 0.4. That's another one. And then I'm going to find that percent by going to my calculator, taking that answer, and multiplying it by 100. And that gives me 40%. So on these, you're going to have not three different answers, but 3 answers that are the same value, but they just look different. So those are the probability that you've experienced before. Here's what we need to do, though. We're going to step up our game a little bit, and we're not just going to take the probability of one event. We're going to take the probability of multiple events, doing multiple things at the same time. So take a moment, and I want you to think about what independent means and what dependent means. Where have you heard those words before? When I think of independent, I think of something that is by itself or it's not affected by other things. And that's kind of the definition that we use when we use probability, is an independent event does not depend on another one or does not get affected, not affected by other events. An example of this would be, and this is one that you'll see very often, is flipping a coin. If I flip a coin one time and then I flip a coin again, my first flip doesn't affect my second flip. The coin doesn't change. My options don't change. Those two things do not depend on each other, and they don't mess up any of the probability. So that's the one that I think of. Or a lot of times there'll be two completely different things. Like if I were to spin a spinner and roll a dice, those are independent things. They have no effect on each other. So another thing that you will hear too is you will see a lot of times maybe this idea of with replacement. And that will mean like we draw a marble out of a bag and then we put that marble back and then we do it again. That would not change the probability because everything's back to normal. So list one of the examples that I had said that maybe is going to help you remember what independent means. Okay. Contrasting to that, dependent. If you're talking about something that is a dependent event or two dependent events, that means that they are affected or they rely on each other. Okay, meaning the first one, okay, affects the second, and so on. Okay, and a lot of times you'll see the word without replacement. And usually these are ones like this. And this one, I don't know why. I like candy. So this is my example, is Miss Bustle reaches into a bag that's got a bunch of different candy in it. Okay, let's say some Reese's, some M&Ms, and some Snickers. She takes a piece of candy out and eats it. Okay, and then she gets another piece of candy. What's the probability that she picked a Reese's and then a Snickers? Okay, because I ate it and didn't put the piece of candy back, those would be dependent events because it changes. It changes what's in the bag. My total changes. What's available changes. So that's kind of the idea of dependent events. So maybe you can think of a dependent example, but put one down that helps you think, or a way that you're going to remember the difference between the two. Okay? So, and maybe this will help you. And the best way I think to do this is to just listen. Okay? I'm going to read these to you. And I want you to think of whether you would say that these actions are independent of each other, meaning they don't change, okay, or dependent, meaning that it changes what's happening. So the first one is this. It says you have a box of 12 chocolates. 6 are mint, 3 are caramel, and 3 are toffee. What is the probability of picking a mint chocolate to eat, then deciding you want one more and picking a toffee? Take a guess. Okay? Or take an educated guess. Write a I for independent or D for dependent. Okay? The keyword in this is then deciding that you want one more. That means I didn't put it back. I decided to grab another chocolate. So this one would be dependent. Okay? B, a totally different situation. It says, what is the probability of flipping a fair coin, like a quarter or something, and getting tails 3 times in a row? So the question we've got to think is the first flip going to change the second one and the third one? Is anything changes between flips? And hopefully you're thinking, no, it's just the same every time. And so this one is independent. Okay? C says, what is the probability of rolling a dice 2 times? First getting an even number, and then rolling an odd number on the second roll. So we're rolling a dice twice. Is that dependent on each other or independent on each other? Or of each other? Okay? Just like the one above, it shouldn't affect the other, so this one would be independent. Option D. You have a bag of 10 marbles with 6 red and 4 yellow. You want to draw out 2 matching red marbles. What is the probability of picking 2 red marbles in a row without replacement? That's your keyword right there. That should be a red flag to you and be a signal to you that it's dependent because you're not putting things back. So this last one is dependent. Okay, feel free at any time to pause this video, go back, rewind, or just take a second to let your mind digest all this information. But if you're good to go, flip over the page and let's move on to the back side. Okay. Now we're going to not just figure out if they're independent or dependent, but we're going to figure out exactly what that probability is. And here's the cool thing, okay? It looks a little complicated, but we've learned these symbols before, and so we can read this correctly. This says the probability of A and B. Remembering that our and is our intersection or our overlap or both, okay? Here's a nice thing. What we do to solve that is we just take the probability of A and multiply it by the probability of B, okay? So it's pretty simple. So we just got to find the individual probabilities of each event, and then we're going to multiply them together. So, example A. A dice is rolled 3 times. I have 3 different things going on, and it's a dice. Okay? Find the probability of rolling an even number, then a 3, then anything other than a 5. So I'm going to be a little extra at the moment, and I'm going to write down, just so I can see what options I have. So I have a dice, right? And my options are this: 1, 2, 3, 4, 5, and 6. For the first one, it wants me to roll an even number. Even number, I'm going to look at my dice. This 2 is even, 4 is even, 6 is even. So that would be 3 options out of the 6 sides. Okay? Then the next roll that I get, next roll wants me to see then a 3. There's only one 3. So that's one option out of the 6. Okay? And then the last time I roll, it wants me to do anything other than a 5. So 1, 2, 3, 4, and 6. That's 5 options out of 6. Okay? Those are my 3 rolls, and in order to find the probability of all of those happening, okay, I'm going to multiply them together. And we've already multiplied fractions. So remember, when we multiply fractions, we multiply the top. We go 3 times 1 times 5. If you can do that, great. It's 15. If not, get your fingers working and grab that calculator, okay? And then the bottom, same thing. 6 times 6 times 6 is 216. That's your fraction answer. That's the probability. Fractions are good because what that means is out of 216 times you tried to do this cycle of rolling the dice 3 times, this event might happen 15 times. Okay, that's what the fraction means. Now the decimal, we're going to go to our calculator and we go, I'm going to move it. We're going to figure out what it is by going 15 divided by 216, and we get 0.0694. So we're going to do 3 decimal places just because that's what I chose. But make sure in your homework you're reading the instructions. So 3 decimal places would mean I'd go 0.069, and then because it's 4, I would just keep it 0.069. So we're going to go 0.069, okay? And then to find the percent, I'm going to multiply by 100, and I get 6.94444%. So I'm going to say that equals 6.94%. All 3 of them are answers, just represented in different ways. Okay? So there's example A. Example B. Give yourself a second. I want you to pause the video. Okay? Try to see how far you can get on B by yourself. Okay? Do it. Pause it. And then give yourself a second. And then unpause it. And I'll walk through it. Wait. Okay. This one's kind of confusing, so it takes a little bit of reading. So maybe you have to read through it a couple times, but it says, in a board game, each player has 3 different colored markers. To move around the board, the player first spins a spinner like the one on the right to see which piece can be moved. The player then rolls a die to determine how many spaces that colored piece should move. On a given turn, what is the probability that a player will be able to move the yellow piece, okay, and then more than 2 spaces? So those are my 2 different events. So the first thing is the spinner. And the spinner here, okay, if I look at it, they're evenly spaced. So I have 1 yellow section out of 3 sections on the spinner. Okay? And then if I'm rolling a dice, I can even look up here at this example. If I'm rolling a dice and I want to go more than 2 spaces, my options are there are 4 things that are more than 2. So that would be 4 out of 6. And then I'm going to multiply straight across. 1 times 4 is 4, and 3 times 6 is 18. That's the fraction. Okay? Then the decimal. I grab my calculator and I go 4 divided by 18. That's 0.222222. So I'm going to do 3 decimal places. So this equals 0.222, which is also, okay, the percentage of, I'm going to multiply by 100, 22.22%. 22.22%. Okay, all three right answers. All three are representing the same thing but can be used differently in different contexts. Okay, this next one. This one is going to make your brain think a little bit, and I want you to think. See if there's an easy way to do this. If not, do it the long way. But it says a fair coin is flipped several times in a row. What is the probability of flipping heads 10 times in a row with a fair coin? Okay. Then it says, what is the probability of flipping heads on the 11th flipped after 10 heads in a row? So that's kind of two questions. So the first situation is this. We're going to flip a coin 10 times. Okay. And we want to know what the probability is of getting heads every time. Okay. So if we think of a coin, our two options are heads or tails. No one's good enough to leave it on its side. So we've got two options, heads or tails. So every time we flip that coin, it's going to be one side out of the two that we want. Okay? So flipping heads every time is going to be 1/2 times 1/2 times 1/2 times 1/2 10 times. But a better way we could write that is we could say it's 1/2 to the 10th power, because I don't want to write it out 10 times. So 1/2 to the 10th power, which means we're going to do 1 times 1 times 1 times 1 times 1 times 1 times 1, 10 times on top, which is going to be 1. And then 2 times 2 times 2, 10 times on the bottom. So I'm going to figure out what 2 to the 10th power is. So 2, and then that little button is our exponent button to the 10th power. And that's 1024, or 1024. So that means 1 out of 1024 times. Okay? Because this one doesn't say to do it in decimals and percents, we're going to leave it just like that. Okay? You know how to do a decimal, you know how to do a percent. The second question says, then, what is the probability of flipping heads on the 11th flip after 10 heads in a row? It's kind of a tricky question. It's trying to get you. But what it wants you to understand is that flipping a coin each time is independent. So flipping a coin and getting heads on the 11th flip is going to still be 1 out of 2. Okay? Or 1/2, or 50%, or 0.5, whatever way you want to do it. Okay? So those are all independent events. Dependent events, okay, are the same. Okay, we do the same thing. We find the probability of A and the probability of B. Okay, but the probability of B is affected by A. So what this says, okay, is exactly what it says down here. When they're dependent, we know what that means. Probability of A and B happening. Okay, we find the probability of A, then we multiply it by the only thing that's different. This says the probability of B given A. That line means given. Okay, so basically that means B is dependent on A, so it kind of changes, and that's kind of overcomplicating it. And you're going to understand more when we do these examples. So we're going to jump right to them. Okay. So we're going to, for example, A, we're going to kind of zoom in here and focus on what's being asked, okay? Give your answers as fraction, decimal, and percents. So there are 7 green suckers, 5 red suckers, and 9 orange suckers in a bag. 2 suckers are chosen without replacing the first one. That's what makes it dependent. Find the probability of picking a green sucker, that's our first pick, then a red sucker, that's our second pick. So the first thing we need to do is figure out how many suckers we have in our bag. So if I take 7 plus 5 plus 9, I get 21. So that's how many total suckers I have. Okay, the first time I draw out a sucker, I get 7 green out of 21. Here's where it gets a little tricky. The second event, I did not put a sucker back. So the second event has now changed. The total has changed. Okay? I no longer have 21 suckers in the bag. I have 20. Okay? And of those 20, I still have 5 red, if that makes sense. Okay? The one I took out was a green. So I still have 5 red, but I only have 20 suckers left inside the bag. And then I do it exactly how we've done it before. I multiply straight across. 7 times 5 is 35. And then 21 times 20 is 420. And then I get my calculator out, if you haven't already. And then we figure out the decimal. 35 divided by 420. And 3 decimal places would be 0.083. 0.083. And then that would be a percentage of, we multiply by 100. And we get 8.33%. Okay? 3 different ways to write it, but means the same thing. Okay? The second example, we're going back to the original bag. We're not working off of what we just had. Now we have 21 suckers in the bag. We're back to the beginning. And it wants to know if we pick 2 orange suckers in a row. So the first time we pick, we have 9 orange suckers out of 21. Okay? I didn't put the sucker back. So again, just like the problem we just did, I only have 20 suckers in the bag, but this time I took out an orange one. So I don't have 9 orange ones anymore. I have 8 in my bag. So sometimes both the top and the bottom can change based off of the first event. Okay? So now I just do it the same way. 9 times 8, 72. 21 times 20, 420. Grab my calculator. 72 divided by 420. And I get 0.1714, which I'm going to say is 0.171. And then the percent for that, I'm going to multiply by 100. And I get 17.14%. All 3 of those will be necessary. We're doing all 3 because your homework wants all 3, okay? And it's just good practice. Okay, last example and then we're done. Okay, pause the video. See if you can do this one on your own. If you're feeling really good, okay, move on, get going on the homework. If you're not, let's go through it. Okay, watch the video. Let's go through it. So, pause it, run through it real quick, unpause, and then check. I'll go through it. Okay, this situation, it says, what is the probability of drawing 3 odd numbers, then an even number from a set of cards that show the first 20 counting numbers if no replacement occurs? Okay, so let's break down this situation. Basically, you've got a stack of cards, okay, and the cards are the numbers 1 to 20. I'm just going to write them down so you can see. 10, 11, 12, 13, 14, 15, 16, 17, 18, running out of room, 19, 20. Okay. We're doing 4 things. 3 odd numbers, then an even. So I should have 4 fractions, 4 different drawings. So the first 3, here's the thing. We should know that there are 10 odd numbers, okay? 10 odd to start and 10 even, right? Because every other number is an even and an odd. So when we originally start, there are 10 odd out of 20 cards, but I'm not putting anything back. So the next one wants me to get another odd. Okay, I didn't put cards back, so this time I only have 19 in my stack. And of those 19, I only have 9 odds. Okay, and then I do it again. It wants me to get another odd, so I only have 18 cards now. And of those 18, 8 of them are odd. Okay, and then the last one, the fourth draw, it wants to know what will happen if I get, not what will happen, what the probability is if I get an even number. So this one, I haven't put any cards back, so my total still goes down. But I haven't picked an even number yet, so my evens are 10. So this is my first odd, this is my second odd, this is my third odd, and then this is my even. Okay? Those are the 4 picking of cards. And then we solve by multiplying straight across. 10 times 9 times 8 times 10 is 7,200. Okay? And then the bottom, I'm going to have to use a calculator, is 20 times 19. Maybe if my calculator will work. Ooh. 19 times 18 times 17 is 116,280. 116,280. That's your fraction. Okay? Now we're going to find our decimal. I'm going to go 7200 divided by 116,280. And I get 0.0619, which I'm going to round to 0.062. Okay? And then I'm going to take that decimal, I'm going to multiply it by 100, and I get a 6.19%. Oh my goodness. All 3 answers, doing work. Okay? Feel free to ask questions. If you have questions, get a hold of me. Okay? Come find me. Come in on Friday, whatever you need to do. Okay? But right now, since you're done taking notes, now is when you need to get on Canvas and get going on the homework assignment 1.2. Okay?